we are going to continue our chapter synthesis of mechanism, and in this lecture we are going to complete this topic three position synthesis of slider crank mechanism by inversion method. Okay, remember that there are lots of variation of inversions are there, two position, three position, by inversion, by relative pole, 4 bar, and slider crank. So total 8 syntheses are there, so don't confuse between them, and whatever asked in exam, first of all clear about what they ask. First check what is the asked in question, because student making mistake in giving the answer, they know all but they misplace the answer. Okay, let's start. So in three position of single slider, first of all I want to give you input and output. So in a single slider, you know that there is a crank, and at a crank there is a connecting rod, and you know that there is a slider. But in all example we have seen up to this point, you know that the line of line is same line of this slider and this origin is in same line, but there is a possibility of eccentricity. Means eccentricity, what is eccentricity? You can make the single slider with some eccentricity also. So in that case you can check here, the crank center is here and slider is here, so there will be some distance between them. You can check here, the center line of crank is here, and line of action of slider is here, so there is some distance is there. Okay, so there is some eccentricity is given. So this is the general idea. Means if you want to make the single slider with some eccentricity, you can make by this, and if the eccentricity is 0, means line of action and center of crank is in a same line, on a same line. Okay, let's start. So first of all, there is a input angle, means initial angle is a theta, and second position there is a theta 2, and third position is a theta 3. Same will be for the crank, initial position, second position, third position. That's why it is a 3 position synthesis. Okay, and as a output, in you know that in single slider as a output there is a different positions are there. If there is a crank in this position, second position is here, so crank will be connecting rod will be in that condition, and slider will be here. Same you can make the third position is if here, so the position of slider will be changed. So as per this 3 input, there will be different output will be there. So first is a, you can check first position, second position, and third position. And with respect to 1, there is a distance. S12 means from first position to second position. This is known as a S12. And when crank move to third, from third position, slider will be here, and total distance from the first initial position will be S13. So remember that all distance, you have to remember that given data will be this. Check this, what is the given data? Eccentricity. Eccentricity means center of crank and line of action of piston will be at some distance. So this type of position will be there. So crank center and line of action of piston, there will be some distance here. You can see this is the distance, you can check here. So there will be some distance. This is known as a eccentricity. And after that, theta 12 means initial to second position, theta 23 or 13, we know that as a 13. Okay, this is 13 means 1 2 3. Okay, S12 means 1 to 2, S13 means 1 2 3. So these are the positions, 3 position, and we are going to make this synthesis, and after that we can get this data. This is the given data, and this link number 1, link number 2, and theta we know. We obtained after making the synthesis. So let's check this figure, and we are going to obtain link number 1, link number 2 and theta by using this given data. Okay, so let's start. First of all, we are going to two lines, parallel lines. First is from the center, and second will be the line, center line of piston, and distance between them is E, eccentricity is given, so it is used. Always remember that all given data will be used one time in our this synthesis. So first make two lines. After that, you know that S1 and S2 means distance is given. So first of all, you have to put this piston at any random place. Randomly put the S1, and from distance S1 to S2, this S1 1 2 distance is given, so second position, and you will obtain this third position. So first of all, you have to make the first point randomly at any distance. Okay, and you have to put this also here point, this center of crank randomly. So there will be always 2 points you have to make randomly. In this case, remember that you have to put the first point and second point randomly, and you will get the link number 1 and 2 after using this method. So after that, what we have to do? So first of all, connect the S2 means second position to initial and third position to initial, and we have these angles theta 1 2 and theta 1 3. 1 3 means from initial to 3. So what we are going to do, from second position we are making this angle theta 1 2 and project this S2 point to S2 dash, and which angle? You know that theta 1 2 is given. Theta 1 2 we know here. This is theta 1 3. Okay, so after that, what we are going to do, same will complete with this third position. Okay, from crank to, we are going to this projection as S3 dash, and angle will be theta 1 3, means third position to first position. Okay, and now this S2 dash and S3 dash, we are going to connect these 2 points with the initial position. Okay, we are connecting S2 dash to initial position, and now this total length is at a midpoint. We are going to perpendicular to that. So you know that you check here S1 S2 dash line, and we are going to bisect at a midpoint and going to perpendicular, and same as S2 dash S1, and making at a midpoint of this line to perpendicular, and at which point these both perpendicular are intersecting will be our final B point. Okay, this is the B point, and which is the end of crank, and we are going to connect this crank and connecting to initial position. And how this you can check, we will get this length of link number 1, link number 2, and if you measure this angle from initial, this is known as a theta, initial position. So in a inversion method, 3 position of single slider, we are going reverse in this method. Okay, so I am going to draw this figure by, okay, so now I am going to draw this again and check. I'm not going okay, I'm going to draw this synthesis again, but I'm not going give any notation. I'm only draw, okay, roughly, so you can figure out how you can draw this. So start with this. First of all, 2 parallel lines. First of all, one is for the center of crank. Okay, I am going to give this center of crank is here, and second parallel line, and distance between these two is a E, already given, eccentricity is given. After that, I will make another point on this line randomly Okay, this is for the first position, means I am going to make here the first slider, and after that, as you know that distance is given here, this S12 and S13, means from initial to second position and third position is given. So I am going to make second position, second position and third position, because I have the distance. Which distance you can check here, from S12 and S13, this distance is given. So I will make this two position, and after that what we are going to do, we connect the second position to initial and third position to initial point, these 2 points, and we are going to now use this angle theta 12 and theta 13, and what we are going to do, we project this second position to whatever angle is given, and we make this at a theta 12, and same will be complete for the third position. And after that, when you get these points, remember that these points we have to join this both point to initial position like this. So for first position and for second position, and we are going to perpendicular to this lines at a midpoint like somehow that, and intersecting point of this is a length of crank. You can get here, this is the crank, and connect it to initial position. So this will be crank and this will be connecting rod and this will be slide. Okay.